All right, let's really quickly talk about slant asymptote. So in the cases where the degree in the numerator is higher than the denominator, then we don't have a horizontal asymptote, but we have something called a slant asymptote. So the question now is, what is the slant asymptote? How do you find the slant asymptote? So let's look at an example. So if this, you can see that this is higher degree than that one, so then we can do long division. And we're using long division on this one because the divisor or the denominator is a second degree, or else we could use synthetic division. All right, so x squared goes into x how many times? X times. Oops, I didn't finish this part. Oh, I did. Oh, yeah. All right, subtract down 9x. And we cannot go any more than that. So if we were to write this in the fraction form, we would get x plus remainder over divisor. Now, which part is the actual slant asymptote? That is the quotient. Y equals x. So it's saying that there's a slant asymptote y equals x, meaning when x is very large, instead of actually going to a constant number like a horizontal asymptote, it's gonna shape like x. Okay, so let's have you practice this next one. What is the slant asymptote? So remember to use long division and look for the quotient. In this question, sorry, one more thing. In this question, it would be faster if you actually just use synthetic division, because notice how you're dividing by a first degree term. So, sorry, first degree factor. So yes, you can use synthetic division. All right, according to the division, you can see that the quotient is x squared minus 2x plus 1, which is also the slant asymptote. So this one's kind of interesting. When x is going to infinity, this graph looks like a parabola. All right, now let's put everything we know together. So we're going to do everything from both chapter 1 and chapter 2. So we're going to find the intercepts, asymptotes, use limit to describe the behavior at the vertical asymptotes and the end behavior as well, and then analyze and draw this rational function. So pause the video and give this one a try. Okay, go ahead and check your answer, make sure it's correct. All right, let's have you try this one. This next one has slant asymptote. Okay, go ahead and check your answers again. All right, in 2.7, we're going to really look at rational functions, but mostly for solving. So let's look at a rational function. Rational function, remember, has to do with the word ratio, and ratio means fraction. So basically, we have a function over another function. So if you have this function, f over g equals to 0, which one, being 0, will make the whole thing 0? Do you think if f equals 0, the whole thing will be 0, or when g is 0, the whole thing will be 0? Well, that's quite obvious. When f is equal to 0, the whole thing is 0, because if you have g equals 0, then it's going to be undefined. So then that is the key. We're trying to find something that makes f 0, but it cannot make g 0, because g being 0 is going to be undefined. So let's solve this question. So I'm going to just kind of show you the fastest way to solve this instead of kind of like going through two methods of solving. So let's just kind of learn the fastest way to solve these problems. So when you look at this problem, the first thing you have to kind of notice is there's a denominator, and that denominator has an x. So there is a potential problem. What's the potential problem? When x is equal to 0, it's going to be a problem. So whatever I solve, that answer cannot be 0. I cannot If I get a 0, then I'm going to say that answer is does not exist. All right, so that's the first thing, kind of identify what x cannot equal to. Then what you're going to do is always get rid of all the fraction at once by multiplying by the least common denominator. And then distribute. That will clearly cancel out all of the denominator. Now what? Very easy. You need to remember this is just solving an equation. Solving an equation always means make it equal to 0. So x squared minus 4x plus 3 equals 0. The next thing is you always ask yourself, can you factor? This looks like you can. X minus 1, x minus 3 equals 0. So x is 1 or 3. Both of them are not 0, so we're done. So pretty simple. Let's try another one. What can x not equal to? Very easy. X can be 4. So just make sure that if your answer has a 4, you need to kind of take that out. Okay, so x minus 4 is the denominator, so we're going to multiply everything by the denominator to get rid of all the fraction. Make sure you distribute. So x times x minus 4, the fraction cancels out, and then anything times 0 is 0. All right, x squared minus 4x plus 1 equals 0. This does not seem like it's factorable, so we're going to have to use the quadratic formula. 4 plus or minus square root of b squared minus 4ac all over 2a. So this is 4 plus or minus square root of 16 minus 4 over 2, which is 4 plus or minus square root of 12 over 2, which is 4 plus or minus 2 root 3 over 2, and that is 2 plus or minus square root 3. This one is not equal to 4, so this is the answer. Now, what happens if the problem is a lot kind of bigger or, oh, I'm sorry, it's hard to, okay, so what if the problem is something like this, where the denominator is kind of complicated? Well, the first thing you want to do is just factor. Because you want to know what is in the denominator. All right, looks like we have repeated factors from the left-hand side as well. So again, the first thing is, what does x not equal to? Not 1, not 3. And then the next thing is multiply by the least common denominator. In this case is, x minus 1 and x minus 3. Okay, and then remember, distribute. When we distribute with the first term on the left, x minus 1 cancels, so we have a 2x times x minus 3. In the middle, the x minus 3 cancels, so we have an x minus 1. And the last one on the right, everything cancels, so just a 2. All right, go ahead and solve this problem and come back and check your answer. When you solve this question, you'll get both -1/2 and 3 as the answer, but we know that 3 cannot be the answer because it's in the denominator, so the answer is just -1/2. All right, this one is very similar, so let's have you just try and solve this question on your own and come back and check the answer. All right, so this question, you end up getting exactly the same numbers as the one that you cannot have in the denominator, so this one is no solution.